All right, G7s. We're going to be talking about the scientific method, which I want you to think of as being broken down into three major categories, and those categories are planning, data processing and collection, and conclusion and evaluation. With the planning being the first part we do before the experiment, the data collection being the experiment itself, and then the processing and conclusion and evaluation coming afterwards. When we look at those, for our notes, if we look at planning a little bit more specifically today, we first start with a research question. The scientific method is always seeking to answer a question, but it's not how do I tie my shoes or something like that. It's something that needs to be testable, something that can be measured. How fast can I tie my shoes is starting to get in the right direction. But at the same time, it's not trying to test too much. We don't want to have too many things that we're looking at. And it's important that you don't already know the answer. Otherwise, there wouldn't be much point to going through the whole scientific method if you already know the answer. So our research question is trying to become short and answerable. After we write our research question, we also want to identify the variables, such as the independent variable, which is the variable that you are going to be changing, and you're going to decide what the different measurements are before you start, and that will always be graphed on your x-axis. So we're going to make a link to our graphing skills already. Then you also have the dependent variable, which is the one that you're really measuring. You're trying to see how it is related and linked to the independent variable that you changed, and it always goes on the y-axis. We also have what are called controlled variables, and those controlled variables are the ones that you want to make sure they are staying the same, not things that are changing when they shouldn't be. And in order to make sure you control them, you must put it into the procedure somewhere how you're going to make sure they're the same. After you've written that down, we can look at examples, and some of the examples, maybe your variables would be time or temperature, maybe it's the number of jumping jacks you did in an experiment, speed or distance, age, and what's important is if you can include a unit, you should make sure you do that. So these are just some examples, not all the possible ones. I'm sure you can think of other ones. Your hypothesis is after you've written your research question and identified your variables, you're going to make a prediction about what you think will happen, including reasons why you think it will happen. So the easiest way to do that is to write it as an if, then, because statement. So you would say, if we do something, then this is what I think will happen because, and give your reason why you think that will happen. It's not just a guess. Okay, so after your hypothesis, you need to identify your procedure, which is, most importantly, clear and easy to follow. Okay, you want it to be able for someone else to do that. It also needs to contain all the information so somebody else can do it just like you did. You can't say, and then we did our method, and then not explain what that is. Someone else who's never seen your experiment should be able to do it based on your written procedure. And make sure it doesn't contain too much extra information. We don't want it to be too long, but just long enough to make sure someone else can do it and that it's clear. You also need to think about your materials that you're going to use. So it's what are the things you need to do this lab, and we want you to be specific. Don't just say water or a ruler, but give the measurement, such as 250 milliliters of water or a 30 centimeter ruler. So think very specifically because your materials are what you're going to need to get ready before you start.